I guess to get started, just to have a little introduction of who we are and why we're experts on European health databases. So Timo.
Yeah, so my name is Timo Kanninen. I'm the Chief Science Officer and also the founder of the BC Platforms. And the BC Platforms is this Finnish company, and we are building this kind of global network of data partners, meaning the hospitals and biobanks, who can provide the data, clinical and genomic data for both the academic and commercial research. And that's why, of course, this is very central thing what we are doing.
And I'm Liina Kamm. I'm a senior researcher at Cybernetica. Cybernetica does a lot of different things, but my research focuses on privacy-preserving data analysis. And since European health databases have the requirement to have all of the communication and all of the analysis to be privacy-preserving, then we are working towards specifically that goal. But now that we're going to go very detailed into very specifically the data protection and privacy preserving part of the topic, but maybe before we get there, we can say in a couple of words what European health databases are for those who aren't really, who don't know, because it's a thing that has been talked about here and there, but what exactly are European health databases?
Yes, and I think that it's very, very important, of course, and I think that it's new, this kind of set of regulations. They are not in effect yet, but I think that it has two main goals. The first goal is, of course, that the healthcare data moves on Europe. So if I'm on holiday in Spain, I break my leg, I go to this hospital in Spain, it would be nice that the doctor could see my health records in Finland. So this is the first goal, so that how the healthcare data moves. But then on the other hand, the other important thing is that how it is possible to do research so that you can combine data from different European Union countries. And after GDPR, it really has quite a lot of regulative issues, and it really tries to make some kind of sense that how that could be done.
Yeah, and I think what is important with European health databases and with European values in general is that we still, if we're exchanging those data, we're giving access to those data, then we're doing this in a safe and secure manner. So we still want to preserve the privacy so that the information doesn't really go to places that it shouldn't, and you get only access to only information that the same doctor at the hospital only gets access to the data that they need to get access to. And also, I think one of the things that the European health databases actually should provide is empowerment to people over their own data. So that is one thing that if you're trying to get into this space, you should keep in mind. Because when we talk about privacy, we talk a lot about unlinkability, and mostly it's unlinkability, when you can't connect the data to the specific person. But what we should be talking about are also the two other privacy properties that are also mentioned in GDPR and that are part of the privacy, which are transparency and intervenability. And these give power to the users. They show how we are using the data, and they show and they give the possibility to actually opt out of different trials or different ways that people might be using our data. So if you're trying to, let's say you are making an app or some kind of web page or some kind of service that uses people's data, then this is one thing to keep in mind. It does involve a little bit more finance to put into that to give transparency and intervenability to people, but it would be a really great benefit, and it is something that European health databases are actually also looking forward to or looking to achieve. Okay, but so one thing why we need to share healthcare data is that when we go to I go to Finland, I start playing ice hockey and then I break a leg. But what are the other other reasons for sharing data? Why can't we just, use our own tiny data set and be done with it?
Yeah, I think that this is very, very excellent question, because now if you think in the big picture, so the artificial intelligence applications will be the biggest business in the future. And now there's competition with the USA, Europe, and China. And I think if you think the funding, the US is one, Europe is good, China probably not so much. If you think the talent, so the US is good, Europe may be a little bit better, China, they also have some talents. But where the big difference comes is that in US, so the access, especially to healthcare data, is much easier. And China, I don't know what kind of regulation they have, probably not much. And then, of course, the AI depends the data. So you need a lot of data, good quality data, to really build this AI. And really here in Europe, we really need to be able to access different data sources to keep competing against USA and China in this field. The other very important thing here is that the diversity. So, for example, the FDA and EMA now, when the pharma company makes the clinical trials, so they have understood that if you just make the clinical trial using white Americans, so you cannot say that this same drug would work in Asian market, for example. And that's why also when we do the clinical trials in Europe, we would need to have data from different countries to really prove that it really covers and works in different populations. And going towards this kind of personalized medicine involving the genomics, so that will become even more important. So at the present, there was just this kind of publication that 96% of all the genetics studies are made from people from European origin. So basically, we don't know anything about the Asian or African genomics. So that is important, really. You can access the data from different countries and continents.
A lot of the trials are also done on men, because the issue is that like a man is, it's like the metabolism of a man is stable throughout the month, but a woman's metabolism is changing like this because of the different cycles, and then it's really easy to just opt to go for just like this is the data for men and so on. But if you have more data, then you have more diverse data, and you might have more data for also available about the cyclic nature of women as well. So you can also focus your drug trials on women and women's metabolism, because it has been shown that a lot of the drugs don't actually work on women the same way they do on men, because the trials there have just not been done any trials. So that's also the diversifying like globally, but also gender-based diversification. Yeah. But okay, so we have a lot of data available. There's just everyone is collecting data, everyone is keeping data. So why exactly? Why can't we then just share it? What's the problem? What's standing in the way of having this just one great big super database in Europe? Let's put it somewhere in the middle, somewhere, let's say in Brussels, and then let everything be there. And why can't that just happen?
Yeah, so I think that the most difficult is, I think the GDPR is kind of good legislation, but I think that the problem what we see in different countries, that the interpretation is very, very different. And also that, for example, the term anonymized data is not defined. So, and that forces the different countries to different interpretations. And also I think that the big thing is that now if you want to do study in certain or different countries, and you need to apply the access to data for the research project. So all the countries, it's totally different procedure that how you can submit the application, how they process it, and how they get the data. So there's a lot of regulations, and the biggest problem really is that it's not unified in the European level, and I think that the European Health Dataspace tries to at least a little bit address this question.
Yeah, and one thing is that I did ask the question, why can't we put everything in a big database? But the clear answer is that we don't actually want everything to be in one place. We don't want there to be a single point of failure that if someone steals this database, then everyone's data is there. Also, GDPR very much works with the notion of minimization of data. So you only want to have the minimal amount of data that you need for your analysis. So that is also something to keep in mind if you're making apps or if you're making services. And if you start collecting data, you always need to know why you're collecting these data. Why do I need to keep this? Is it really important, or do I just want to keep it just so that I have it because it's really difficult to find data? That is not the reason for keeping data. A reason for keeping data is if you have something in mind for the data, what you aim to do with the data. So minimization is one thing. Another thing is, I think that we have a lot of data sets that are very widely tiny databases with really important data, but they're not connected. We don't even know that some of these exist. But let's take, for example, if you're talking about a startup that collects data about some kind of specific disease, and then what you want, you would like to use these data, but how do you use them? So one thing that our European health databases also might accomplish is that they help to get these data from the tiny apps, from the startups, to the personal doctor's desktop. So that, okay, I collect data about my weight every day, or I collect data about my diet every day. But I have this information is in my phone. It's also probably in some database, but my doctor never finds out about this. But if that data, or at least some kind of, maybe not all of the data, but maybe some information that might be important to my doctor, and I agree to send it to my doctor, then my doctor might have to get this information about me that would be important for them. So the data sharing, consent-based sharing, or for analysis, for research purposes, is important. But so what we're trying to achieve is privacy of individuals. We don't want everything to be in one place. But what are the different solutions for achieving this? Because I know that you're working on one thing. So can you tell us about that?
Yeah. So I think that basically we see three different kind of framework how this can be approached. So first one is like this kind of trusted research environment. This is, for example, what the Finland is using. So they have defined the technical requirements for this kind of environment where you can put the pseudonymized data, where researcher can see only the data approved and can do the analysis defined on this analysis protocol, but so that no data and no even analysis results can be exported. And what also this European Health Dataspace tried to do is to have this kind of European definition of this secure environment for basically copying the pseudonymous data in different countries and analyze it together. But then in top of that, we have two very promising approaches. So the first is this kind of federated analytics. And the idea is that the analysis is done inside the hospital or biobank firewall, and then only the results like p-values, means, standard deviations are sent back to central server, which statistically combine it. And according to GDPR, so for example, the p-value or average of the height is aggregated, like anonymized data, and that data can be moved between the different sites. And the federated analytics, so you can do a lot of things using this technique. And also this kind of AI model training. So we have this kind of federated training model where you can send the model to Helsinki University, then to Tartu University, then Karolinska University, and it learns and goes around, and then you get the result. Or then this kind of swarm learning, which is, for example, used on the Tesla, so the cars. They send this kind of summarized learning results on the central point when it's combined. And the third very promising technique is this multi-party computation, where Liina can tell more.
Yes, we're actually working. We're working on secure multi-party computation and trusted execution environments, and this means that you can analyze data without actually seeing the values. So there are cryptographic measures that we can take so that the data are shared between different parties, but they're shared in a way that no one can actually, even the data administrators. Do not have access to individual values. So you can do your analysis, you can have an overview of the data, but you don't see individual values. So you can't actually pinpoint people, but you can get aggregation results, for instance. What we're also working on is to combine this federated learning with a multi-party computation or trusted execution environments, because federated, well, again, there has been research done that if you send out a model, you can still attack the model and see whether a specific person was in this data set. And if we're talking about, let's say, disease data sets for different diseases, then you don't maybe want someone to know that you might have depression. Maybe that's something that's personal to you, you don't want anyone to know about it, so that the model might leak that information. And then what we can do is we can share the models actually using multi-party computation, and in that case you can't see the model. You can still do analysis on your own data, but you can't see what everyone else's data was like. So that is a way that technology can actually help you achieve privacy. And we've also done. What we also did was we incorporated trusted execution environments, which are basically, it's like a tiny enclave on your processor into which you cannot see, and no one can see in there, even data administrators and so on. They can't see in there. Whatever is going on there, you don't see it, but computation on data goes on. And otherwise, everywhere else, the data is encrypted. So we incorporated that into also a health app, so that the health app trains a model, but your supervisors actually don't see your data, specifically your data that the model is trained on. So that is one way that technology can help in this. I think.
So one of course, it's no free lunch kind of, because the federated analysis, so there's one requirement that how it can work, and the requirement is that all the clinical data is harmonized to common data format. Yeah. So if you think about, project for European Union countries, and then all the data is in different format. So you have to get access to individual level data to format it so that all the data is in the same format. But luckily, there are now this kind of big wave happening in Europe also, and it's this kind of OMOP CDM data format. So it's originally developed by the FDA in the US, because the FDA, so they have this kind of requirements that after they have given the approval to sell the drug, so they also need to monitor that how well it works. And then they find out that, okay, all the hospitals in the US so had different electronic health record systems, different formats, different everything. And then they started to think that this doesn't make any sense. Would it be possible to make this kind of generic format where all this health care data can be stored? And then they just need to write one script to analyze all the 100 hospitals. And this format is now, it's open source or open format maintained by this kind of academic institution, and it's now spreading also in Europe. And for example, this kind of European Union EDIM project, so they have invested 20 million euros funding this kind of projects where the hospitals, they have converted their data to OMOP format. And if all the data is on that format, so then of course the federation works very nice.
Yes, so the recommendation here is that if you're doing a health app, use common data formats. Use the formats that are used already everywhere. Don't come up with a new data format. Because if you're using something that can be easily incorporated or easily integrated with other solutions, then there is a bigger chance that your data will be incorporated, and you will have to do less work to actually transfer the data into these formats. So I think a lot of the governmental health databases are doing work on transferring their data. So that is the future. And also about the privacy-enhancing technologies, then the European Data Protection Board has also kind of indicated that the privacy-preserving, different privacy-enhancing technologies could be used as ways of helping along the privacy-preserving part of the. Like if you want to join your data, then this is the way that you can use that to join your data. But I think we're now almost out of time. So
maybe we have time for a couple of examples.
Yeah.
Yeah. So I think that one very practical example what we are doing, it's this kind of European Union funded project called OncoValue. It's led by Helsinki University. And the idea here is that they predict that next 5 years there will be 100 new cancer drugs coming to market. And it's very hard to say that which drug work for its patient. And what the project is doing is that you take the genome sequence of the normal cell, you take the genome sequence of cancer cell, you compare and see what are so-called driving mutations for the cancer. And then what you can do is that we have this kind of network of European hospitals. So you can select the patients with certain cancer diagnosis, then this driver mutations, and then that I want to try this drug. It sends the query to all these cancer clinics and says that, for example, in Portugal, 80% of these patients with this diagnosis, this genomic profile, was improved when using this drug. And then you can collect the statistics from different countries and then make the decision that if the drug is good for this patient. And there's so many things you can do if you really have access to data. And again here, if the protocol sends 82%, so it's not violating the privacy at any way, but it's still very, very useful information when thinking that what drug would work on this Finnish patient.
But then, what would be the take-home message from your side then to today?
Yeah, so I think that very good point. Stick to the standards. That's happening, and then also I think that if you develop any AI model, so you can develop it, but then you still need to validate it on the different population, and this is also the requirements of the FDA, for example, if you want to sell the model on the clinical use. So.
Yeah, and I think from my side is that it is possible to actually take advantage of the different value that big data provides to analysis, to AI, but also do this in a privacy-preserving manner so that we keep to our European values of privacy and data protection.
We have some time for questions as well. Yes. And I do actually have some questions, so thank you very much, people, for sending your questions in a timely manner. So we just got one a couple of seconds ago, which was the EHDS requires that the secondary use of data should take place only in closed processing environments. Where does this leave PETs or PATs?
Yeah, so the closed environment, so basically it means this kind of environment where the data don't go out. So you can see, you can use the keyboard, mouse and screen, but you cannot get anything out. And also there's some kind of hints that the European Union would like to create this kind of European Union approved environment so that different countries could deposit their data there and analyze it together.
Okay.
Well, privacy-enhancing technologies are actually wider than what I was talking about, because I was talking about very specifically about multi-party computation and trusted execution environments. Also, the trusted research environment is one privacy-enhancing technology. Also, pseudonymization and anonymization are. So pets there are probably that you don't just give like all of your data freely to the environment, But probably for secondary use, you will want to at least anonymize the data. And if you're doing it in a closed environment, then anonymization might be enough of a privacy-enhancing technology to allow this. So because we don't, like, anonymization can easily be attacked, but if you have additional measures like being in a closed environment, or you have, let's say, confidentiality clauses or something like that, then that would also help you with using anonymization.
Okay, thank you. Actually, that's all the time we have for questions. But thank you very much for your time.